Industrial Robot Insight, also known as IRI, is a single platform capable of monitoring robots from all major manufacturers, which analyzes metrics of predictive maintenance and energy consumption. Traditionally, the industrial production environment, where robots are the focus, have been caught up in a series of problems that affect the quality and efficiency of the production. Among the most common problems we find the corrective maintenance, in which a sudden robot breakdown could lead to the stop of the entire production plant. On the other hand, we find the preventive maintenance and its tendency to change components which are still working properly. This conservative approach results in unnecessary and high costs. IRI allows for predictive maintenance of your robots. By means of their monitoring, you will be aware of your plant's activity. Through the robot data, you will gain a deep understanding of the robot's status as well as to foresee robot errors. High energy consumption of production plants is an important problem that all manufacturers want to reduce in their immediate future. IRI provides energy consumption information of the robots and identifies the most consuming processes on the plant. Understanding how your plant consumes will help on the process of energy saving. Because IRI is a single platform, it works with all the robot brands. IRI comes in a simple appliance format through which robot data is processed. Due to its simple implementation, IRI can be materialized either on-premise or cloud infrastructures. Also, a custom web interface is provided to access results and visualize the data. IRI can be easily installed in your environment, attaching the appliance to the robot's data sources. Immediately after, the data will start being processed by the system without the need for further configuration from the user. The results will be easily accessible through the web interface and ready to be analyzed in detail. The web interface represents plant data through 3 different perspectives, each one showing a different level of abstraction. On the first perspective, one finds the plant map and a summary of the status and energy consumption, grouping robots on cells or work areas. The second perspective offers the detail of each of the robots within the selected area, where existing alarms and warnings are reported to the user. The last perspective is presented for each robot and collects the detailed information. Robot status is projected on quality indicators, which are both presented globally and per individual axis.